Hey, boys and girls. So, this graphic organizer, which you will have access to on Google Classroom, is going to give us a summary of the three types of rock that exist on Earth, specifically in the crust. So, I want to start with the igneous rock, which is the one on the bottom left of this organizer. So, igneous was most likely the first rock type that ever existed on Earth because in the beginning, while Earth was forming, it was kind of a fiery, hot, liquidy mess of magma and lava. So this is most likely the first rock type because an igneous rock, if we read from the definition, forms when hot liquid rock cools and hardens. So igneous rock used to be liquid. Liquid meaning it used to be magma or lava that cooled down and hardened into an igneous rock. So there's two types of igneous rock. One is an intrusive with an in the beginning. Those are igneous rocks that formed inside the earth. And since they formed inside, intrusive, they cooled down slowly because the inside of the earth is hot. So it took them a long time to cool down. And as a result, the crystals inside of those rocks are larger. Okay, we can see them and they're larger size crystals. There's also an extrusive igneous rock with an EX. They formed outside of the Earth where it was cooler, so they cooled quicker. And since they took less time to cool, those crystals didn't have as much time to form. So extrusive igneous rocks may have no crystals at all, or they may be very, very tiny that they're tough for us to see. Now, when we looked at the mystery rocks, there were some examples of igneous rock. One was basalt, and that did have crystals inside of it. So basalt is most likely an intrusive igneous rock. We had granite, which also had crystals, another intrusive. However, pumice and obsidian didn't have crystals, so they would be extrusive and they cooled quickly. So again, igneous rocks, very common in the crust. They used to be liquid magma or lava that cooled and hardened into the igneous rock that they are. So they are close to volcanoes because that's most likely where the magma or lava came from to make those igneous rocks. So you can kind of see a picture of an erupting volcano next to the igneous rock in this diagram. I'm now going to go up to sedimentary rocks. In the word sedimentary, I highlighted the word sediment. This is a very important word to know. Sediment is little pieces or particles of things. So when we talk about sediment, it's little tiny pieces. And a sedimentary rock is made of little tiny pieces. Now, there's some things involved. First of all, we have to get these little tiny pieces. So other rocks have to break up or things have to break up to make the pieces. And then all these pieces have to travel. Pieces can't travel on their own. So they're moved by water, they could be moved by wind, and these little pieces, they could be pieces of rock, pieces of sand, shells, sticks, even living things. Water moves them, and eventually they settle at the bottom of bodies of water. So they could settle at the bottom of oceans, they could settle at the bottom of lakes, streams, rivers, and they settle and they settle and they're pressed together into layers which eventually harden into rock. This is a long process. By long, I mean thousands, hundreds of thousands, millions of years to make these sedimentary rock layers, which give us the sedimentary rocks. So again, they have to come from little pieces. We're not dealing with lava and magma anymore. These are rocks that came from little bits of things. So some examples of sedimentary rocks were sandstone. Think about it, sandstone. Little pieces of sand came together to make the sandstone. Limestone. Little pieces of lime came together to make limestone. And finally, conglomerate. Conglomerate means conglomeration. That's a bunch of stuff. Little pebbles, all kinds of other types of little pieces of rock came together to make conglomerate, which is kind of like the junk rock, random stuff stuck together for a conglomeration. Now, if we look at this graphic organizer, there are two lines that lead from sedimentary and igneous to our third type of rock. Now, the third type is metamorphic. Metamorphic rocks have to come from the other two types of rock. So metamorphic comes from sedimentary and igneous. Now, the word metamorphic has the word morph inside that I highlighted. So this word morph means a change has happened, a metamorphosis. And that change is the sedimentary or igneous rock changed into a metamorphic. Now, this can only happen deep in the earth. So I wrote that on the side here. This is an internal process. So deep in the earth, sedimentary or igneous rocks get exposed to a lot of pressure. There's pressure inside the earth and a lot of heat. And these rocks actually change into a metamorphic rock. Now, some examples from the kit of the mystery rocks were slate. Slate used to be shale. Okay, shale basically got crushed in the earth into flat slate. Marble used to be limestone. Limestone, heat and pressure changed it into marble. So that's our metamorphic rock. All of the rocks on the planet fit into one of these three categories. Okay, igneous, sedimentary, and both of those could eventually become metamorphic if a change occurs. Now, next, we'll talk about how these three types, rocks can constantly be changing between the three. So igneous could become a different rock, sedimentary could become a different rock. That's called the rock cycle.